Hello, and welcome to the SAF Magazine podcast. I'm your host, Anna Simet. Hope you're all doing well. On this episode, our guest is John Worrell, Vice President of Sales at Filtration Technology Corporation, otherwise known as FTC. John, welcome to the podcast. Thanks so much for coming on.
You bet, Anna. Thank you.
To start, tell us a little bit about FTC, just a brief history of the company and what you guys do.
You bet. So FTC is a Houston-based filtration company specializing in pleated medias, high-efficiency pleated medias in four primary categories, those being liquid-solid separation, gas-solids filtration, liquid-liquid separation, and gas-liquid separation. The company was founded by a gentleman named John Hampton in 1987. Specializing in the oil and gas industry, and subsequently have grown to more downstream processes, including gas treatment, refining, and even food and bev.
So, John, FTC changed the shape of traditional cylinder filters. Why did you guys do that?
Well, I think it's first of all important to understand that filter performance can be directly tied to usable surface area. All things being equal, the more usable surface area that you have in a given system, the more dirt a filter will hold, and the higher the efficiency a filter will be at removing a given contaminant size. This can be proven via Darcy's law, which we use to calculate flow through any porous medium. And we know, according to Darcy's law, that dirt holding capacity is indirectly proportional to flux rate or flow per unit area. So we know that the more surface area that a cartridge can hold, the more contaminant a cartridge can hold. So over the years, many traditional cylindrical cartridge designs have been modified to try to pack as much surface area as you can get into a given cylindrical cartridge. And that's been done via increased pleat count, tighter pleat spacing, putting taller pleats in a cartridge, or even staggering the pleat heights, which we call kind of W pleats, in order to maximize the amount of surface area in a given cartridge. Furthermore, we've varied the cartridge diameter, and because we can get more cartridges in a given housing with a smaller diameter. So there's been a lot of variations in cartridge diameters, lengths, and things like that, all in the intent to try to improve the amount of surface area you can get in a given housing. Now, there's a problem with a cylindrical design, and that is that all things being equal, your pleats will always be spaced tighter at the ID than they are at the OD. So what this does is it can result in a partial use of the surface area at the ID because the pleats get so close together that the dirt does not quite penetrate down into the ID of the cartridge. And we call that tip loading. In other words, the contaminant does not fully load throughout the surface area of the cartridge. And so, therefore, you pay for surface area that you don't fully utilize. And subsequently, with the cylindrical designs, you can only get so many cartridges in a given vessel design, no matter what diameter you use, because, you can only get so many circles within a circle and you have wasted space in the vessel. So this is where the Invicta design comes in because we solve two fundamental problems. The first problem is that with that cylindrical design, we now replace that with a trapezoidal design, which really maximizes the number of cartridges or minimizes the wasted space in the vessel design itself. In addition to that, because the pleats do no longer pleat around a circumference, they are pleated in a linear fashion, the pleats are evenly spaced on the ID and the OD, so we can maximize the number of pleats per linear inch. So what does that do? When compared to traditional cartridge designs in the cylindrical geometry, Invicta basically increases the surface area as much as 176% in the same size vessel.
Really great, thorough answer. So, what does all of this mean for customers?
Well, for customers, they basically want two primarily concerns addressed. Number one, will this filter remove the contaminant to a level that I need? And number two, how long is this filter going to last in my process, right? So, as stated above, the performance of the filter is directly related to surface area. So, all things being equal, increasing the surface area or decreasing the flux rate or flow per unit area basically reduces the drag forces. And that's those forces that are imparted on the cake or the dirt load on the surface of the filter. So as that cake begins to build, as we can reduce that flux rate, we reduce those drag forces. What that does is it allows for a thicker cake to be built on the surface of the filter, and it also increases the efficiency of the filter. So that means basically for the customer, what that means is that the filter is going to last longer in their process, give them longer run times, and reduce their filter spend. And number two, it's going to hit their spec with regards to efficiency requirements for their downstream process fluid contaminant requirement.
Okay, that makes sense. So, what kind of filters are these, and what industries will use Invicta filter technology?
So the short answer is Invicta can be used in any application that a traditional cylindrical filter can be used. The only difference is the shape. So with regard to chemical compatibility, we have multiple media options to meet those requirements. From a removal efficiency standpoint, Invicta can be used in any application where you would have a traditional cylindrical design from zero point 0.5 to 100 micron plus.
Okay, so what if the customer already has a filter vessel installed? Can their current filter vessels be converted?
Sure. In fact, we have a pretty unique process that we call a tube sheet upgrade. Basically, the way that this works is, many customers don't want to replace a vessel just to go with a new technology. So we have this a tube sheet upgrade process that allows for them to upgrade their existing vessel without the need for a hot work permit or a confined space entry or anything like that. And basically, it doesn't modify the vessel in any way. So the process would be similar to this. We would get a general dimensional drawing of the vessel itself. We could use that drawing to provide a budgetary quote with an estimated payback on the upgrade. So if the customer wants to proceed based on that, we can send a team out to take a detailed measurement of the vessel itself. With that detailed measurement, we would bring that back to our office and prepare a firm proposal to the customer, whereby they would review, and upon satisfactory review, they would send us a PO, whereby we would start fabrication. The tube sheet and elements are then scheduled for delivery along with an installation date that's coordinated with the customer. And then an FTC team goes out on site to either install and or supervise installation of the system itself. So the nice thing about this is it is fully reversible. There is no modification on the vessel itself, and you get all the benefits of increased surface area, better filter performance without the need of purchasing a new vessel.
Okay, so what about rental vessels? Do you guys have them available?
We do. FTC has a full fleet of rental vessels ranging from all ASME code, ranging from 150-pound to 300-pound design. They're all flange connections. We offer them in carbon steel and in 316L stainless steel from 8-inch diameter up to 36-inch diameter, handling flow rates in excess of 1,200 GPM.
Okay. So, John, I think that's all the questions I have for you. Is there anything else that you want to add?
Well, thank you, first of all, for giving me the opportunity to talk today. And yes, I mean, I would think that the primary thing that I would want customers to come away with would be the understanding that, number one, if you've got an application whereby you're using or having frequent change outs of filter elements, or if you're not meeting spec, we have a full team of FTC folks that would be happy to talk with you to determine whether or not we can apply this Invicta technology. And once again, I think that the nice thing about this is it's a technology that would allow for longer run times, fewer change outs, better filter performance, all with the intention of driving down your total cost of filtration.
All right. Well, thanks so much for that. And I really want to thank you, John, for coming onto the podcast and telling us about FTC and the Invicta filter technology. And I look forward to chatting with you again in the future.
You bet. Thank you very much.
Thanks so much for tuning in. Until next time.